Here's a simple but detailed explanation of the diagram, step by step. 1. Pod needs to talk to a service. Your application needs to connect to a Kubernetes service called myService. Since it doesn't know the service's IP address, it starts by asking CoreDNS to resolve the service name. 2. CoreDNS resolves the service name. The pod sends a DNS query to CoreDNS. What is the IP address for myservice.default.svc.cluster.local? CoreDNS doesn't know this immediately, so it asks the Kubernetes API for information about the service. The Kubernetes API responds to CoreDNS with the service's cluster IP, e.g., 10.96.0.1. CoreDNS sends this IP back to the pod. Pod sends a request to the service. With the service's cluster IP, 10.96.1 in hand, the pod sends its request to the service. The traffic is intercepted by kube-proxy because kube-proxy is responsible for handling all traffic destined for cluster IPs. HA4. Kube-proxy routes the traffic. Kube-proxy recognizes that 10.96.1 belongs to my service. It checks the list of backend pods managed by the service and decides which backend pod should handle the request. For example, if there are 3 backend pods, pod A, pod B, and pod C, kube-proxy might send the request to pod B based on its load balancing algorithm. A5. Backend pod processes the request. The selected backend pod, pod B, receives the request and processes it. Once the processing is complete, pod B generates a response and sends it back. 6. Response returns to the pod. The response flows back from the backend pod to kube-proxy. Kube-proxy forwards the response to the original pod. Key points. 1. CoreDNS resolves service names to IP addresses. 2. Kube-proxy ensures traffic is routed from the requesting pod to the correct backend pod. 3. The service acts as a virtual load balancer, directing requests to healthy backend pods. This detailed process ensures seamless communication between pods and services in Kubernetes, even if the backend pods are spread across different nodes in the cluster.